Hello, students of mathematical studies, and welcome back to another video on probability. Yesterday, we took a look at a couple of questions. There was the 8-quarter game where you pay $2 to take a chance at winning 5, and there was also a card game, and the assignment was to work on both of those. Now, probability is a pretty young branch of mathematics. It's actually just a little bit older than calculus. It was developed in about the 17th century. For years and years and years and years, there had been this thought that mathematicians would be immoral to study probability because it would encourage gamblers to do more gambling. Well, actually, it went the other way around. It was the gamblers that encouraged the mathematicians to do more probability because a couple of guys were involved in a game that they had to end. There was this big pot of money, and they were playing some game where one person was winning by quite a bit, and the other one still had a chance to win, but it was pretty remote, and somehow they had to stop. I don't know if somebody had to go home for dinner or if the authorities busted in or what happened, but at any rate, they had to stop this game. So somebody sent a letter either to Pierre Fermat or to Blaise Pascal, who then wrote to the other one. And Pascal and Fermat hashed out the beginnings of probability theory. What they basically did, one idea was split the money 50-50 because the game couldn't end. Another one idea was give it all to the person who was in the lead. And the one they came up with was to split it by some percentage because there was a certain probability that the one who was in the lead was probably going to win. But there was also a probability the one that probably wasn't going to win possibly was. And so they analyzed these two possibilities. What are the odds of this person winning at this point and the odds of this other person winning at this point, and split the money that way. Well, we're going to take a look at a little bit of a gambling problem, a card problem. It was the one where you have a deck of cards, as I have here, and let's go ahead and shuffle it, very exciting. And you draw 2 cards, and if one of them, but only one is a face card, you win. Did we win? We didn't win. So let's try again. We're 0 for 1 right now. So we shuffle again. We grab 2 cards. Did we win? We won. So 1 win, 1 loss. Right now we're at 50-50. Is this a card toss? Law of large numbers. We can't say it's a card toss after just 2 tries. Here we go. We've lost 1 win out of 3 tries. We're down to a 1/3 percentage or fraction. Here we are again. We lose again. 1 out of 4. Interesting. How many times am I going to do this? I don't know. 2 out of 5. 40%. Let's stop right there. That's a 40% chance. I mean, do it yourself if you want. Try 10 trials and see what happens. So our question now is, we won this game 40% of the time. Were we lucky in that maybe we should only win 1/4 of the time? Or were we unlucky and maybe we should win half the time? Maybe it should be a coin toss. So let's figure this out. And we are going to solve this by using a tree diagram. But we're going to use that tree diagram with proportions. So even though I grabbed 2 cards, we're just going to pretend that they were card 1 and card 2, the same way the marble problem worked in terms of breaking it down. So the options for the first one was either there was a face card or it was a non-face card. Now, as it was a face card, well, there are, as we talked about with the deck of cards, there are ranks and suits, and the face cards happen to be some fraction of that. Yes, face cards are 4/13. No, they're 3/13. 3/13 of all of the cards in the deck, because 3 of the ranks happen to be that. So the odds of getting a face card were 3 out of 13. The odds of not getting a face card were all the rest out of 13, or 10 out of 13. When it comes to the second one now, the second one, we look at these 2 branches. If we already had a face card, the odds of getting another face card can be a little bit harder to figure out now because we can't just work with the idea of the deck in the abstract. Now the deck is a real deck that has 52 cards. 1 has been removed. And if we drew a face card to begin with, now 11 of the remaining 51 cards is a face card. So the face card branch here is 11 51sts. The other one is all the rest of the 51, 40 non-face cards out of the 51 remaining. So we have that. On the non-face card side, we originally had the idea of the non-face card being 10 out of the 13 ranks. And now out of the remaining 51 cards, there are 12 face cards that are possible out of the 51. Yes, that's a reducible fraction, but so what? And on the other side, the non are going to be the other 39. Because 1 of the 40 non-face cards already got drawn. So now we're looking at 39 out of 51. Both of those are also divisible by 3. You could break that one down if you want to. We're just going to look at the percentages. Now, what we need to do in order to win this game is realize we could have won with face, then non-face. This is a winner. And we could, or we could have won with non-face face. So this is a winner. So we had this percentage chance of winning and this percentage chance of winning. And therefore the overall odds of winning this game were, so were we lucky with our 40% or unlucky? So all of that was absolutely fantastic. What we're going to do now is have a little assignment based on this, but we're going to change the game. This card game now becomes, instead of a 2-card hand, it's going to be a 3-card hand. So instead of having a tree diagram that's going to have 2 layers, our diagram is going to have 3 layers. The rule now is that in your hand, you're going to have to wind up with exactly 2 face cards, not 1, not 3, but exactly 2. So out of each layer is going to be face, non-face, working the same way. But now you have to start considering how these things change as you go down to the second card and the third. So again, 2 branches coming out of each thing, but there's going to be 3 layers. So we're going to have top layer, 2 branches. Each of those is going to have 2 branches. And each of those is going to have 2 branches. So use the percentages and whatnot and work that one up and write up a paragraph on that and submit it. Thank you so much. We will talk about the coin problem with the $5 and all that a little bit later.